Hello and welcome back. It's your host of JavaScript Jabber, Solder.js. This week on the show, we have the illustrious, magnificent, intelligent, creative genius, Mikeal Rogers.
Hey. How's everybody doing?
We also have Aimee Knight.
Hey, from Nashville.
Just Nashville, or was it the, what's it hole?
The what?
Bad joke. Ferdinandi, the Vanilla JS guy.
Hey, it's Mr. Solder.js over here. Mr. Vanilla JS.
And our actual should-be host, Charles Max Wood.
Yeah, that's me. The devchat.tv guy. This episode is brought to you by Triplebyte. Applying to programming jobs sucks. You have to put the right keywords in your resume, you spend hours and hours on the phone screens and take-home projects, and that's assuming the company even responds to your application. Well, if you're a software engineer, Triplebyte can help. They work with over 400 top tech companies, from big names like Dropbox and Adobe to exciting startups. You do one brief online interview with them, and if you do well, you go straight to final interviews with the company on their platform. It's like the Common App for software developers. Triplebyte does not look at your resume or where you went to school. All they care about is if you can code. I've helped dozens of software developers with various credentials get jobs, and this looks like a terrific way for you to get in and get interviewed and get a job without a lot of the hassle and overhead. You can go check them out at triplebyte.com/JSJabber. That's triplebyte.com, byte as in 8 bits. As a special offer for listeners of this show, if you take a job through Triplebyte, they'll offer you a $1,000 signing bonus.
Chris, real quick question. Have you always been doing Vanilla JS? Did you start that project?
So I actually have nothing to do with vanilla-js.com, and that site infuriates me to no end. But I have been really, really focused on Vanilla JS for 5 years now, and I use the term because it's what everybody else does. So from a marketing perspective, It makes sense. But I have very slowly and deliberately associated myself with that term to the point that, people sometimes think that site is me. But it's a little bit too serious. And so I get beginners are constantly how do I download this thing? There's no instructions on the site. And, it causes more confusion than so people who've been around the block a few times think it's hilarious. But I hate the effect that it has on beginners.
That's funny. So I was actually just going to apologize because I accidentally overwrote that package one time. I'd written a joke package called Vanilla, and that one was already published, and I published and it worked. And I was like, I guess there's not a package there because I didn't actually check. And this was a while back, and I wrote the original NPM registry. So I had admin in that CouchDB, and so I could just overwrite. I didn't know that I would just overwrite people's packages if it didn't, if I didn't actually manually check. So somebody.
The more you know.
Yeah. The person got really mad, and I was like, "Oh my god, I'm so sorry. I did not mean to do that." And we put it back together. But yeah, those were the old days of NPM before there was a real company and things around it. So.
So everybody knows who Chris Ferdinandi is, but Michael's a little less known. So, Mikeal, why don't you introduce yourself for, the people that have never heard of JavaScript, for example?
Okay. I'm Mikeal Rogers. I started to get involved with Node really, really early on, the first week that it was released. Did a bunch of sort of Node core stuff, not a ton, but a lot of stuff around streams and the HTTP API. I wrote Request, which was one of the first libraries. I helped write the original registry for NPM, did a lot of stuff around there. Worked on also a lot of sort of CouchDB related stuff. I created the PouchDB project a long time ago as well. And then, I did the first series of conferences, NodeConf around Node.js. When the IO.js happened, I was involved in that. And then when the foundation happened, I actually ran the foundation for the first couple of years, the Node.js Foundation, which recently just became the OpenJS Foundation. They merged. So that's sort of my history around Node and JavaScript and things like that.
Awesome.
Boy, that brings back some memories. Some of that stuff.
It's a good time.
So, Chuck, since you're on the show now, I'm going to let you go ahead and take the lead with the question asking again, all right?
Yeah. Well, I set this up because I kind of wanted to sprinkle in some beginner content, and I was thinking, let's talk about Node basics. And of course, when I think of Node, I think of Mikeal. So I thought, okay, well, we'll have Mikeal come on and talk to us a little bit about Node basics, and just we can kind of get some ideas as far as what Node is and how people are using it and all of that good stuff. So Yeah, do you want to just give us a brief intro, Mikeal, as to what Node is and how people are using it and how people could get started with it if they're not as familiar with it?
Sure. I think with Node, it's important to remember what JavaScript was like 10 years ago, which was when Node started, and what it's like today, and how those are very different. And also, I think the original conception of what Node would do is not necessarily what people are using it for now. So there's some mismatches there, right? So like Node was started before we had async await, before promises were standardized. It actually originally shipped with a version of promises that was like not like any spec that anybody's ever done. They were awful. And so those got backed out, and it took on this sort of callback API. There was no binary type, like a reliable one in JavaScript yet. So we had to invent one. The streaming interface didn't exist. Generators didn't exist. Not async generators, just no generators at all in the language didn't exist. So a lot of what Node has inside of its kind of core primitives are these things that were created before JavaScript as a language and as a platform had kind of caught up. When you look today at what JavaScript is like, and Node now takes a version of V8 with all of those features, there's some big mismatches between the way that Node core works and the way that you're probably going to want to use Node, and the way that people in sort of modern JavaScript use Node for both front end and for back end, right? So I think that there's a lot of newer tutorials and newer libraries that you need to look at. And, the number of dependencies or stars or history in a library, these kinds of like quality things that you look for in other languages might not actually apply in Node.js right now.
Regarding that, I got a question for you. So I think of requests as being one of the things that when they show the black hole diagram with NPM, like request is almost at the center of that density. Do you still feel like request serves its purpose well, or is there something that's smaller, lighter that would be better, or what? Like, because it's grown to be huge.
So we actually just announced that we're kind of deprecating request. So I would say like, no, it's not. So to back up a little bit.
Let's back up and talk about like why it was there in the first place, because it has been invaluable over the years.
Oh yeah, for sure. So I mean, Node.js was released at a conference called JSConf.eu that my friend Jan ran, and after that conference, he said, "Oh, hey, has anybody written an HTTP proxy in this yet?" And nobody had, and like that was how I learned Node and got into Node. Actually, it was like that weekend I wrote an HTTP proxy, and it was like faster than the proxy that I'd worked on for 5 years in Python. So I was like, maybe I should move to this thing. It's doing the things that I need it to do a little bit better than Python. So maybe I should migrate. Anyway. And so that like getting involved in sort of the HTTP layer was like the first thing that I did. And using Node Core's HTTP client was like not very fun. And so the first sort of reusable library that I wrote was an HTTP client. This was before NPM even existed. So this was like a thing that I was just like pushing on GitHub, and people would just have to download that whole repository if they wanted to use it. As Node evolved and took and like standardized its APIs, Request was driving a lot of that alignment and then adopting it immediately. So if you look at like all of the really early commits inside of Request, you see that it's just evolving along with Node, and even Node itself is sort of taking on changes. So when streams started to get standardized, that cuts down a lot on the code. When we introduced this sort of agent API inside of Node Core, which is how you manage the connection pooling in HTTP Keep Alive, that was like exposed in a way that Request could then adopt it and use it. One of my favorite contribution that I ever made to Node Core is actually a one-line commit in the stream interface where streams have a pipe method, but a source always knows about its destination because it's a method that hangs off of it, but a destination didn't know about its source. So I added this event where when you pipe, it will actually like call an event with the source on the destination so that you know about your input and output. That's what enabled the Request one-line HTTP proxy, right? Like that's exactly like the Request, like the smart proxying that happens inside of Request, that was added into the platform so that we could do that in Request, and then Request evolved along with that. So, and when you look through Request code, there's a lot of code in there to handle ancient APIs inside of Node. And then I ended up doing a huge rewrite of the HTTP client at one point, one of the many rewrites of the HTTP client in Core, I should mention. A lot of people have done this. This is not like, I'm not the only person who's rewritten most of HTTP. Anyway, so Request really drove Node and Node drove request. And that's why it was such a popular library early on. It was showing, what Node could do at the time. And a lot of people that were doing, even basic examples on stuff like Stack Overflow using the HTTP client, they would use request. So it's now one of the most dependent on projects like in the Node ecosystem, right? Like most backend projects rely on it. I think NPM still relies on it. I think they want to ditch it at some point, but the problem is that there's just not good enough proxying support in other libraries yet. So it has become like this really kind of core project. At the same time, it has been really hard to keep maintenance and contributions coming into it. Like I've struggled to keep up with the pull requests that are coming in. We've onboarded several contributors, some like really great contributors now that are doing amazing stuff. Fred Schott, who works on Pika, for instance, and Pika is like an amazing project that I'm following really closely. He early on did a lot of like cool request stuff as well. So it's been a great project. I've met a lot of really great people, but especially lately, it's really, really struggled. And as you look at the changes that have happened in the language, taking on promises, for instance, introduced like some really problematic challenges for request updating its API. We were really like, request is stretching the inferences that you can make from taking in callbacks and returning streams and stuff like that. So it's just not, it hasn't been able to keep up with the language and the platform. And we haven't really been able to keep up with maintaining it all that well. And we kept having all these ideas for like, what will the next big version of request look like and blah, blah, blah. And in the meantime, like other people have done better stuff. And even I wrote a different library that I kind of like better for these new patterns as well. And so I kind of decided one day that the right thing to do was actually not to do a big new version. The right thing to do was to deprecate the project. Because if we just try to take all of that market share and sort of brand awareness around request and roll it into the next version, we're definitely going to get more users than any other new HTTP client, but we're probably not actually going to be better. We're going to be straddling this line between all of the old stuff and all of the new stuff. And I think that it's better to make a clean break, actually. And the best way that we could make room for a better library and for a clean break was actually to just slowly deprecate. So, we're putting it into maintenance mode for a year, and then we might do something that actually does deprecation warnings within a year or so. So that's sort of the story there. And
so back at the beginning of that, you said something that was really interesting was that you were doing something in Python and you found Node to be a better tool. And I think maybe that would actually be a good segue into...
Can I jump in for a second, though? Because I know a lot of folks, they get in using this language or that system or what have you. And so they may not know what streams are, because you've mentioned streams a few times. So do you want to just cover that really quickly, and then we can...
Sure. So streams are primitive inside of Node.js. There's also, confusingly, a standard for a thing called the stream in the browser now, and a couple newer APIs have taken on that as well. A stream is basically an object that represents something that is going to hand you chunks of data. Like it's going to give you multiple parts of data over time. And these are really important to use in a way where you're taking streams and sort of stacking them together and sending them together. Because what will happen is that like you will do, let's say like you want to serve a file, and that file is like a gigabyte, and you serve it to a mobile phone. That mobile phone is not going to be able to take a gigabyte of data as quick as you can read it off of disk, right? And so what you want to do is you want to connect sort of the outbound socket to this inbound reader. And if you make that connection, if you have like in the language or in the primitives, sort of some kind of fabric tying all of like this source and destination together, then when the client can't take any more data, you actually just stop reading, right? And you pause it, and then you start iterating. You can iteratively pull data in just as quick as it's reading it. Other languages that don't have these primitives or just don't do as good of a job with kind of non-blocking interfaces, what ends up happening is that now that whole file just comes into memory, and you're just sitting there like on that memory waiting for the client to be able to take it. And it really limits your ability for one process to deal with like multiple different clients. And it's just this explosion of memory usage. So no matter which way you slice it, it's not a great pattern if you don't have something like that. In the language now, we have this thing called async generators. Async generators are much more of like a language level primitive for dealing with and manipulating data, like iterative data in this way. And if you look at the new browser stream APIs, they actually have async generators attached to them. So you can use them like an async generator. And even in Node Core today, and I think as of Node 10, they attached an async generator to core streams. So that is not every stream that you get in the Node ecosystem. If you pull them out of NPM, sometimes these won't be attached. But all of the streams that are out of core or subclasses of core streams, you can use them as async generators. So you can use the for await, let x of blah syntax and iterate over them that way. So that's what a stream is.
Makes sense to me.
And yeah, and to go back to Age's point about Python. So at the time, what I was doing with Python was, writing proxies and dealing with a lot of like iterative data. I was also, I was at Mozilla at the time, and I had built this tool to sort of tear apart the platform and be able to test it and pull at all the UI components. Similar to kind of what Selenium does if you use Selenium, but it also worked on all of the Chrome, so all of the buttons inside of the platform. Mm-hmm. And then, but you needed a platform language to launch the browser, to get test results back into the platform language, all of that kind of stuff. So there was a lot of this like event system stuff that was happening over in like a non-blocking browser in JavaScript APIs that I then had to hand off to these like blocking interfaces on the Python side. And I've at a certain point in time at that time, I had used all of the libraries that they had for doing non-blocking. And non-blocking in APIs in Python suffered from this problem that the entire Python ecosystem was built on the standard lib blocking APIs. And if you used a non-blocking API, you were like often this, sub ecosystem of people that have just been doing that. So one of the benefits of Node even in the first week that it was released was you could see, okay, one, these non-blocking interfaces work really well and they're very fast. Two, the V8 VM at that time was like so much faster than Python. I mean, now it's even faster, much faster than Python. Python has not gotten much faster in the intervening 10 years, and V8 has gotten significantly better. Just performance in VMs and JavaScript is unbelievable. But most importantly, I could see that as an ecosystem sprouted up and we started I didn't know that NPM would happen, but you could see that there would be something like NPM and people would be writing these libraries, and those libraries would be on top of these non-blocking interfaces rather than the blocking interfaces in Python. So there was just like all of the growth and potential you could kind of see there if you were looking at it from the perspective that I had in 2009.
So what are some of the things that you think? So speed is obviously one. I feel like performance is a really great reason to use Node for, if your alternatives were something like Python or Ruby. I feel like Node is good in terms of performance. So one, I want to know if you feel like that's fairly accurate, and two, what about for learning or creating your first type of program on your own? Is Node good for that, or is it more challenging, do you think?
This is where my perspective has definitely changed over time. And especially the years that I was running the Node.js Foundation, I got a much kind of bigger picture view of what people were doing with Node and where the growth was and how the community was growing. To give you some perspective, at that time we had, I think like between 2 and 4 million users when we were starting the foundation, but we had 100% growth a year. And we had no reason to think that it was slowing down. So we were predicting these numbers that people thought were outrageous, but all came true, basically. Now Node is definitely the largest programming platform in the world. It beats every other programming platform, including Java, which was holding that record for quite a while, up until just a few years ago. More developers use it every day. In fact, we're starting to reach the point where more developers use Node.js every day than you actually get in world statistics for how many developers there are. Because the reality is those statistics look at people who, as a profession, are doing software development. And the web, and Node is now like a part of the web, just touches more people than you classify as engineers and developers. Like a lot of people build websites that actually have a career doing something completely differently. So yeah. Anyway, I think that the best way to build a new application is to use the web. I think that you should build a web application. I think that you should use, and in building a web application, you're going to use JavaScript. And Node is like a part of that equation. So if you're using, React or Vue.js, all of the compilers and the tool chains and everything are written in Node. And it helps you to know a little bit about how Node works if you want to interface with those tools, deal with plugins, stuff like that. Knowing the differences between Node as a platform language and the browser JavaScript environment is a good way to learn that. Also, you may have backend needs. You may have things that don't only work in the front end. And it's great to not be switching to another language, for one thing, when you have to write those. And two, there's more opportunities in different service providers to use Node than any other language. Every function as a service offering in the world supports Node right now. And other languages are supported in some people's offerings and some not. Node's performance characteristics on serverless are nice. Node is always optimized for startup time. We've always viewed that like the longer your startup time, the longer it takes for a developer to sort of see their work. So that's always been an important kind of performance indicator for Node. And that startup performance time matters a lot in services like Lambda and other functions service stuff. I see Aimee has a question.
Yeah, I have a bunch of questions, two that are appropriate for right now. So the first one is, so AJ asked about like Ruby and Python. Those I think are more like beginner friendly languages. What about, I do feel like just from like personal experience with friends and stuff, like the Go community and Rust is starting to like steal away a little bit of usage from Node. I'm just kind of curious your thoughts on that in general. Like, do you agree? Do you think maybe some people are jumping the gun too much on things?
So those are two really different questions. I'll answer them in reverse order, though.
And I asked that too because like neither one of them were. I don't even know if Rust was around when I got into Node. I think Go was.
Rust, Go,
Rust
and
has been around
Node
for a long time.
Well, and I also know,
So,
like they're very different, but they can be used for the same thing too. So
okay, so first of all, some people don't realize this. Node, Go, and Rust were all released within a year of each other. So they're all about 10 years old now. Rust literally just yelled at people not to use it for the first 5 or 6 of those years. they were.
I do remember that. We had a show on it. Yeah.
Yeah. They were very clear. Like, we are still breaking things. Like, just don't use this. So it's a little unfair to sort of put them all next to each other. But Go has been trying to get developers to use it about as long as Node, and it has a nice growth curve compared to other platforms, but nothing compared to Node. It's hard to put this into terms that don't sound like you're trying to exaggerate, right? Node's growth is not like any other platform language, like a language that you run on your computer. It is much slower than the growth of web development. Web development is unbelievably fast and is still growing, and is an unbelievable number of developers. But Node was really able to tap into that, and so it has platform growth that is completely different than these other platforms. I used to spend a lot of time tracking these numbers. And one thing that is really interesting about the numbers of all of these platform languages is that with the exception of Ruby, none of them have actually seen a decline in growth. All of them have been growing at a good, relatively stable rate. This idea that like people are moving from one language to another, it's really marginal. What the majority of growth in any programming language is new people adopting it, because we're just making more developers than we have existing developers. Development is like a very, very fast growing field, and the need for people to write code is just growing exponentially. So if you want to see, who is growing the most, it's really just who is capturing the most new growth. It's not so much who is, stealing developers from one community to another. So if you look at Go's growth, it's relatively stable over this period. Rust growth is doing pretty well now. It's like up and now sort of flattening. Like I said, Ruby actually did decline. I'd never seen that since I've been tracking these numbers. Python started to do a little bit better about 5 years ago than it had before, which is rare. Usually after you've been around for 10 years, your growth rate sort of stabilizes. And there's
Python 3 for the win.
I
got adopted.
I don't think it was Python 3. I think that what actually happened was that So Python's been doing this. It's really a story of community work working out well. Python spent, not exaggerating, 10 years in the academic community trying to make headway, trying to get academics and universities to adopt it. And they put all of this work into SciPy. And I know some of those people, they've done a tremendous job of doing community development in academia. And when ML started to come back and AI started to become a thing again, that started paying huge dividends. It was just an amazing language to do that in, because they already had this huge community writing all these algorithms and doing all this tooling work, and it just became a really good environment. Python as a language is not particularly well suited to any of the problems in ML and AI, actually. But they just have a great community for that. And it turns out that the community is actually kind of more important than having a language that is perfect for a task.
Well, and everything's written in C and Python anyway. I mean, you're literally scripting C. Right?
A lot of those ML libraries are like actually in Fortran and then bound to with Python. Some of like the really really old scientific libraries.
Yeah, so, I mean, it's like,
these are people that wrote their thesis around this algorithm, and nobody's re-implemented it ever since.
Like Python's the best way to write Fortran and C. That's what it seems like to me then.
Yeah. I mean, by comparison, Node is terrible to write C in. The binding layers are really expensive because a lot of C libraries that you tap into, not these algorithms, but a lot of other ones are use blocking I/O. You just can't use them in Node. This was a huge problem in the first year of Node. Every other language that you look at, it's like their Postgres binding and their MySQL binding are all just the same thing on top of a C library. And then in JavaScript, like we had to write a Postgres adapter from scratch in native JavaScript. It took a while.
But it's so much easier to get Node working. Like try to install Python on something. Like there's so many quirks. Like if it comes in the package manager or whatever, fine. But like Node, you can just unzip the folder, put it in a directory, and it works. And goes like that too. Like the other languages, not the Ruby and Python, good night.
Yeah, I mean, there's two things that I think have done the most around Node's growth. Well, I guess three. So one is that early on, so 10 years ago, there was clearly going to be a need for a fast, non-blocking language for backend. And Node kind of won that. And it won it because we were very fast and very good at that. And if you look at the first few years of Node, a lot of systems people were coming into it. Then what happened was, then it was just the web. Like we ended up being the place where people wrote, compilers and all of these front-end tool chains. And that's just a much faster growth space than anywhere else in any other thing that languages do, at least. And the funny thing is that we like, in the first NodeConf that I ever ran, we asked the panel sort of like, so what should you not do in Node? And one of the things they said was you shouldn't do things like scripting and compilers in Node. And that ended up being like one of the biggest things that you do, because it turns out that just being in JavaScript is actually more important there, where you're not kind of fracturing the community and being like, okay, well, let's write this in some other language and then get JavaScript developers to use it. And then you have this really hard problem of turning your users into maintainers and contributors to the project.
It rode on the coattails of jQuery, I would say, definitely. jQuery was right at its peak when Node was announced, and I think that had a huge boon to it. And JavaScript had no standards. Like there was nothing to agree or disagree with. You couldn't say like, I like this style or I don't like this style, because it was completely Wild West. Everybody did everything whichever way they wanted without any cohesion. Underscores, camel case, snake case, like everything was completely bogus, whichever way that person wanted to write it.
Yeah. I mean, so when Node started, we thought that the language was just done. Like they had tried to do a new version of JavaScript called, was it ES4 or ES3? I think it was ES4.
It was ES4.
Yeah, it was ES4, yeah. And it was like this big overhaul of the language, and all these features that are actually coming in now were supposed to be part of it. And it was a colossal failure. And it was completely backed out. And then ES5 ended up just becoming like a small iteration with just some really nice stuff, but just a very tiny iteration on the language. And so we saw this kind of, in the early Node community, we saw that as a benefit, because if you look at like what's happening in Python, they're developing a language and an implementation of it as a platform. And there's always a tension between do you solve this in the language or do you solve it in the platform? And obviously language changes are going to take longer than platform changes. And so we felt like we had this opportunity where the language isn't changing. It's clear that we can't actually solve these problems in the language. And we should just focus all of our attention on fixing them now in the platform and creating good APIs around it. Of course, what ended up happening is that in the intervening 10 years, JavaScript as a language committee has actually gotten better at evolving the language than maybe any other language except C++. They have a staggering rate of achievement in not just adding things to the language, but not breaking the language, getting the language adopted. Now, pretty much except for Node, every dominant, platform that takes Node, every browser, auto-updates. And so that's just completely changed the dynamic of how quickly that you can upgrade the language and upgrade really just the whole web. So the platform is really caught up, and a lot of the things that Node did that the platform didn't provide are now provided by the platform. And there's this weird transition period that we're at where there's all of this new stuff that you really should be using, and it's a better way to write code. It's much simpler for everybody to use, but then there's all of this old kind of cruft around that even if you don't depend on it directly, ends up inside of your deep dependencies. And then those turn into bigger bundles and all that kind of stuff.
Speaking of dependencies,
Yeah.
I want to ask some questions. And I am not making an opinion when I state this. I'm just asking questions. So I'm going to preface what I ask with that. I'm just curious. I feel like you have kind of mentioned this, I think, but for people who might not already be aware, like, what is your opinion on alternate registries, alternate CLIs, stuff like that?
So I've tried a lot of the alternate CLIs, and I haven't had a lot of luck with them. I think that there was a period where NPM didn't seem to be releasing quite often enough, at least clients. That's over. They've done a lot of really good work and have been iterating quite a bit. So they have most of the features that people want now. I think my questions about NPM are much bigger, looking into the future. So, I mean, so it's important to think about like why NPM was so successful and what it did differently than other package managers. So every decision in NPM is really optimized for creating an ecosystem, which is what you want from a package manager. You want a package manager that is focused first and foremost on enabling an ecosystem. That means people depending on other people. That means cumulative sort of network value coming out of the package management ecosystem. So the fact that you never have to intervene to fix a package is really important. It means that you can just continue to rely on packages and they can rely on packages. And at no point do you have to ping a maintainer or rip apart that code in order to figure out like, oh, hey, this is where this mismatch happened. Much like requests, the Node module system and NPM co-evolved together. Like Isaac was working on both at the time and even took over running Node for a while. And so when you talk about sort of like why NPM was successful, especially early on, a lot of that is actually also in the module system itself. And so the fact that you can rely on two different versions of a module is really important. That means that if you had an older one and somebody else has a newer one, I can just get both of those versions and I never have to go and resolve and fix some kind of issue. And these kinds of optimizations have other costs. Like, if you're trying to bundle this up in the browser, you're going to end up with extra code. If you want to use this in the browser, you have to use a bundler. Like, you can't just use this stuff without a huge tool chain in between. And a lot of those trade-offs, I think, are still the right ones. I think that if you're building a package manager, you need to optimize for ecosystem. But we're now in a place where the platform has caught up and the module system the platform provides is significantly different than the one that Node provides. And so there's now a new opportunity, I think, for newer ways of doing dependency management and packaging that are not NPM related. I mentioned Pika earlier.
Yeah, that is something I've been looking at too.
Pika is really interesting. So if all of your modules only use the new style module syntax, which means that they don't really work in Node, which is fine. But if you're using just that syntax, you can actually use Pika, which is like not really a compiler and bundler. It just like presents these in a way that you can import them directly into the browser. You don't need any of this tooling. I mean, like literally, I mean, you need some tooling to maybe download that package, but you don't need tooling to bundle it up. You don't need, a extra special dev server that's doing, dynamic regeneration of all the code and everything like that. If a module changes, then its e-tag will change because the content changes. So you're using HTTP again. There are some big performance drawbacks of this. Like if you rely on 1,000 modules, then you're going to get 1,000 HTTP requests. So there are other performance optimizations that you need to layer on top of it to make it work better. But the fact that like you can use view source and without a source map or anything, see the actual file and it makes sense and it's real code, that's kind of amazing. That's like a big, if you can collapse this giant tool chain that we have into something that simple, everything is so much easier to debug. There's so much less code in between the code that you write and where it actually gets executed in the environment. And I think that it's hard, these tool chains are cyclical, right? Like we go through these cycles where we build up this huge tool chains and all these frameworks, and then we go like, oh, okay, like now my biggest frustration is the framework and the tool chain. Like, let's just throw all this away and start over and do something simpler now that the platform is caught up. And I think that it's hard to look at things today when you look at this huge stack of a framework like React and Webpack and Babel and just like unbelievable amounts of code, and look at the changes that have happened in the web platform since those tool chains started. Like we now have a module system. We now have async primitives like async await in the browser. We have, async generators. We have we have an import function that will just do, dynamic importing after the fact so that you're not always blocking initial execution. all of that, when you add it up, you go, okay, what would a new tool chain look like? What do we actually need of all of this if we're just doing something in a newer, more modern way? And so, I think that like this is the time. this is the like over the next year or two, we're going to start to see. And I don't know if it's going to be Pika. Like I'm not like putting all of my chips on that, but I think it'll be something like Pika. I think that that this change is significant enough. And I think that in some ways, there's always a tension between, okay, how much work do we do to make the whole ecosystem continue working? I mean, by the time that one of these things happens, there will be 1 million modules in NPM. Like not an exaggeration, 1 million. Like they're already at like 800,000, right? And it's growing pretty quickly. So by the time that we're talking about seriously moving to a new thing, we're going to be literally talking about not using 1 million modules. So there's always a tension between, okay, do we start over and do the new thing, or do we try as hard as we can to keep it, all of that stuff and port it over?
Well, what about just using, I mean, like if you just automatically updated Git URLs for SHA sums that like match packages, if you just iterated over all 800,000 of them, I mean, like it's
No.
It would take a couple hours. But
Yeah, really.
No, they're not written for the new module system though. Like they're not written for they're written for Node's module system. So they're not going to work. Or in some cases they're actually written for a newer style module system that only works actually inside of Webpack and not just inside of the browser. So like it's not going to work that way. You're still going to need the compile chain in between. I don't know. I mean,
but why not use Git for hosting rather than
So I don't. That's a bad idea. It's a bad idea.
The amount of caching that is involved at NPM,
Yeah.
like it is.
Yeah.
Yeah.
But with Git, you get all the caching automatically. Like.
No, no, you don't. So what I actually work on now are newer content address data structures that use Merkle trees. So the data structures that I work in day to day now actually look a lot more like Git and have much better sort of syncing and caching semantics, but those aren't really surfaced in Git. So in Git, you get like one hash for the entire source tree, which means that if you change one thing, then the entire source tree has to be updated again. You can't actually. So if you're just using it in the way that you're talking about, where you're just caching it to that one identifier, internally inside of Git, when you do merges, when you move things around, it has this brilliant like Merkle tree syncing structure, but that's not exposed to you if you're just using it as like a dumb package registry. So it's highly problematic.
It would be better than zip though, wouldn't it?
So it turns out, I did another one of these tests the other day. It turns out that like we really underestimate how good gzip is. So if you don't compress files, but you do deduplication using this algorithm called Rabin, which is so everyone who like Git internally and anybody who takes like a file that you think is just going to change iteratively, and you want to chunk that file up in a way where you maximally deduplicate chunks between different versions of the file, you use this algorithm called Rabin, and it's like pure magic. You just like apply it to a file. It was written, I think, for rsync, but it just knows like the smart way to look at boundaries and different characters, and then chunk the file up that way. So if you chunk a file up that way and you have like literally hundreds of versions of the file, actually the test that I ran was on the request library. So every release of request, I chunked up differently in the static file layer. You still end up with 3 times the amount of data as taking the entire file tree every time and gzipping it. Because gzip is really good. It turns out that like our compression libraries are incredibly good. So sorry, it turns out no.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
Then the other question I wanted to ask, and then I'm done with my questions, I think, for now, was about import maps and how you think that's going to affect Node.
So I just started looking at this, so I haven't completely gotten my head around it. Miles Borens, I think, has been working on this a little bit, or at least advocating it, and he pointed me at it the other day. Yeah, no, I think that it's a really good idea, and I think that it solves a really interesting problem. So we have something like that. We solved this problem in a way in Node using package.json, but this adds a much better primitive that'll work in the browser, and I think that it certainly helps. This is going back a little bit, but in early discussions around how ES modules would be implemented in the browser, there were multiple specs for and approaches to what the API would look like in the browser for pulling in modules and how mutable it would be and how much you could change it and program it. Isaac Schluter, who built NPM, who now runs the NPM company, who built Node's module system, worked with them on one, what was it called? I'm like forgetting what it was actually named now, though. But it was a much more dynamic way to do that, so that you could do something like Node's resolution algorithm, but implement it in pure JavaScript in the client. They ended up not going that way for a bunch of reasons, most of them kind of performance related, and concerns about like, well, what happens when two people try to load up their module algorithm in the same browser context? Like, how do you manage that? It's painful. So instead, they went with something that was much more straightforward, and now they've been trying to sort of add different features that we kind of lost in these more advanced APIs, and this is one of them. And I think that it's definitely a good way to go. Yeah, it's good stuff. Yeah, there were a lot of different threads that we're pulling out there, so I don't know if I completely answered all of them or not.
That is good for me and all of my questions, and I'll stop hogging the mic now.
One thing that I'm curious about is what of these things that we have talked about, or maybe some of the things that we haven't talked about, do developers need to understand in order to get the most out of Node?
So even though you shouldn't use them, and I'm gonna I helped write streams. I worked on a lot of the stream stuff. You shouldn't use streams. You should use async generators. But it's important to understand streams as a concept and understand when Node or a Node program is giving you a stream, so that you can decide what to do with it. Which I think you should actually just pipe it to a transform or a pass-through stream, and then use an async generator on it. But it's really important to understand when something is a stream, because it's a very different value type than anything else that you're working with. First, I would start with just general JavaScript knowledge, actually. So like if you know new modern JavaScript, so you're using async await, you're using kind of class keyword stuff. If you get all of that, you can use any JavaScript library pretty effectively, I think. The main things that are very different in Node are the stream type, and then how the module system works, how modules get, how NPM works, how module installation works, that kind of stuff. Those are the main things that you really need to know, especially if you're just doing front-end stuff and messing around with plugins here and there. Those are the big ones that you really need to understand. I think that Node is still a very thin layer between you and the operating system. So a lot of Node's APIs and what it provides, like I could give you a list of learn the file API or learn the socket API or whatever. The reality is those are pretty close to the metal in terms of what the operating system gives you. And so if you know operating systems well, or other platform languages, it's not that hard to pick those up. And if you don't know those, then the hard part about learning them is going to be learning what a POSIX operating system will give you and what operating systems in general offer you in terms of sockets and files and stuff like that. Those are the same constraints, I think, in most languages, especially any other language that does non-blocking operations. So Go and Rust and even a lot of modern Python, actually, they have newer, better async primitives. But yeah, I think that if you're just starting out, learn JavaScript, learn new modern JavaScript, and then pick up Node from there. Find libraries that fit that model. When you see their README, are they using sort of newer style syntax, that kind of stuff. I'll make a couple quick plugs. I think that you should use standard JS style just to not have that argument. And standard JS is has packages for every linter. So any linter that you ever want to use, you can really easily adopt standard style. And that just cuts down on the amount of byte shedding and things that you're worrying about in terms of syntax. And once you're using a linter that has a good rule set like standard or any other really good rule set, those linters will also show you a lot of obvious errors early on. So you won't hit a lot of JavaScript has a lot of loaded guns that they hand you and point them at your foot, right? So you can do a lot of things in JavaScript that are bad and will mess up your program. And it may run once well, and your test may run once well, and then immediately when you have an application up, it'll break. So yeah, linters will fix a lot of that. So those are the things that I would point at when you're first learning JavaScript and first learning Node. Yeah, I think that the main thing with Node is to remember that there is a long history there. And a lot of the tutorials that you're going to find are using an older style of all of that stuff. So avoid them, pick up the new stuff.
I feel like that's the plague of JavaScript in general, is 90% of the tutorials are wretchedly terrible. I think JavaScript is probably the hardest language to learn out of any because of the Wild West heritage. If you pick any other language first, you'll probably have a better experience.
I don't know. I mean, I was in the Ruby community for a long time. I went and tried to learn how to do iOS development for a couple of years. They all have this problem, right? Where the tutorial doesn't have a date on it, doesn't have a language version on it or a framework version on it. And so you get in and you're trying to figure out why it's so flippin' hard and why you're getting an error while you're trying to figure out what you're doing. And then it turns out that when you finally do figure out how old it is, you're going, oh, well, this is from 4 years ago, so no wonder. And so then you go find something, you figure out what the current version is of the framework or language, and then you go and you find a tutorial for that, and all of a sudden it works a whole lot better.
Yeah, like we all have that problem, but I think in JavaScript is especially bad because people don't even agree on what the language ought to be. Like there was no consistency on syntax or style, and even now, like it's beginning to look so much more like C# than JavaScript.
I mean, like I've been involved.
Here we go.
I've been involved in some of those arguments, and there are certainly. 8 years ago they were trying to turn it into Python, and now people are saying they're trying to turn it into C#. I think that there's a couple of things to keep in mind. One is that like more people learn JavaScript every year than any other language. In fact, JavaScript is still basically doubling every year. So half the people in the JavaScript community learned it this year. So it may be difficult for some of us, but often I find that JavaScript and Node are more difficult for people that are intermediate to advanced developers to learn than new developers. It's surprisingly easy for newer developers to pick it up. And I think that has to do with a big mismatch in how you approach learning it. If you're trying to approach it from a bottoms up, like a fundamentals all the way up perspective, which is what you tend to do when you're a more advanced developer, you're like, okay, what are the primitives here? And then how do I kind of stick them all together and move my way up the stack? JavaScript's a really hard language to learn because there's no consistency there. But if you're learning it from the top down, if you're saying, I have a task that I want to complete, or often there is already an application up and I need to do something to it, JavaScript's a pretty easy language to learn. The syntax is pretty simple. There's a lot more tooling and environments for you to use and sort of mull your way through. So like, a browser is a live environment for you to use. The tools inside of the browser are better than almost any IDE that you have for other compiled languages. It's better than anything you have in Go or Rust to do debugging. And that's just like already installed in every computer in the world. When you look at the tool chains for doing linting, for doing the compile stuff, like you have just a much more advanced tool chain for debugging than anywhere. Like, just this year, when I'm starting to see now, like somebody wrote a library somewhere where now when you hit an error in your program, they will print to the console 4 lines around that error, point at it, and do syntax highlighting in your console, right? And we went from never seeing that to now every program that I use, I see that in. Like my test runner uses it, like the compiler uses it, everything. I think that like we really tend to underestimate like the evolution of the tooling and how good it is compared to other platforms just because of how many people are writing it.
So if I may though, so my whole thing now is teaching beginners JavaScript, and all of the stuff you just described is incredibly non-trivial for at least the type of beginner that I interact with to set up. So like I agree with you, but that the tooling is amazing, but it's also really complicated and is one of the number one things my students cite as what gives them anxiety when they're trying to learn modern JavaScript. It's like, why can't I just open a text editor in a browser and start coding stuff? Like, especially people who did HTML or CSS first and then they're trying to pick up JavaScript. Like all the stuff around it is really overwhelming. I think modern JavaScript is certainly a hell of a lot easier to pick up than 5 or 6 years ago when we were still fighting the like IE versus Firefox versus Chrome kind of wars. But like, yeah, I don't think I'd go so far to say it's easy.
Well, the browser tools are incredible. Like, I mean, and
I agree with that.
Right?
I think sure.
I mean, I agree that like, so Webpack and the entire compile chain is a big wrench in all of this, right? Because it means that, no, I can't just pop open the tools now and just run stuff because like my application does not run in the environment that I'm just typing things in that console. Like there is this huge difference, and the compile chain like really changes things, right? People all the time that have been doing like, some kind of framework like React or something for years now, right? And they're pretty good at it. And they still just never think to like, okay, well, like I'm running this thing and I need to just get at this object in the console. Like where do I get that? Like they're trying to like, pass it off to some component and then like attach it to some DOM element. And I'm like, it's the window, just attach to the window object as some variable. And then you can pull it in the console. It's that easy. Because like they never went and just learned the basic platform stuff, like the vanilla JS that you're talking about. That said, it's incredible what they've been able to get done without doing that. Like they learned it they took a different approach to learning it. They just wanted to build applications and they learned the framework on the way down, and they're missing a bunch of pieces and they struggle with that. But also like it's always surprising to me how much they're able to get done. I think also we forget, like we don't even talk about, like we don't even consider them web developers anymore or JavaScript developers, but there are all these people that have like some PHP framework that they're using that spits out a bunch of stuff. And inside of that is a bunch of JavaScript that they have to manipulate on like a weekly basis. And so they drill into that. And we used to like have them at web conferences, right? Like when the Ajax experience started, it was mostly like people that did PHP and were like learning jQuery so that they could like make their PHP thing better. Like that's what they were doing. And now that we don't really consider them part of the equation when we say like JavaScript developer, but that's still a huge constituency. Like people that are just making stuff happen on the web like that are a huge constituency. And a lot of the growth that we see in toolchains like is from those people. Like those people are now adopting toolchains like React inside of those PHP frameworks. So yeah, I mean, like I think, if you want to sit down and say like, I want to become a JavaScript developer and I want to be an engineer and I want to have a career in engineering, then you're going to approach learning in a very different way. You're going to learn it from the ground up. You're going to learn the fundamentals on up. And that is much harder in JavaScript than other languages. It does not have a clean break. Like Python to Python 3, when we added new syntax, it does not have a clean history. If you try to Google how to do stuff on the web and you're not using jQuery, you're mostly going to get answers that just tell you how to do something in jQuery, and it's really frustrating.
That's why I use vanilla JS with all my stuff. It's literally just a differentiator for Google.
Yeah.
So what I'm hearing is JavaScript's the new PHP, and Stack Overflow driven development has never been easier from my console. That's the Node basics right there. PHP your way to Node with the Chrome console. Got it.
I mean, I just want to jump in here with a few other things. I mean, one thing that I ran into when I was learning JavaScript, like really learning it, not when I was, okay, well, I'm going to plug in jQuery here, and here, and manipulate the DOM, and I'm just going to ignore what JavaScript actually does. Yeah, it wasn't so much that I was trying to understand it from the ground up. It was just that there were some things in it that, speaking of this inconsistency, that I expected to work differently because they work differently in the other environment I was working in. And so, that was what would throw me off, is that the fundamentals were different and that they were different in ways that weren't always things that I could draw a straight line to in every case. And that's what screwed me up. And so then when I got into it and I was like, okay, well, I'm just going to learn JavaScript for JavaScript, then it became, oh, okay. So this it thinks about these things differently. But yeah, there really weren't any consistent internals. I just had to get used to the way that some of these things work that were different from what I was used to.
So what are the basics of Node.js then?
So coming back to the cyclical nature here, I remember people said the same thing about jQuery 12 years ago, right? They were like, these people aren't learning JavaScript. They're not learning the web. They're just learning jQuery. And
I was learning how to do a freaking job.
And they don't know where the trade-off is. And it's the same thing now with React and these other tools. And I think that it will, again, come back around that the platform is caught up, and vanilla JS will be a thing again, and people they'll probably call it modern JS to distinguish, but I think I've already seen people kind of using that. Yeah, and I think that it'll come
back. There goes my SEO.
I want chocolate chip cookie dough. Just saying. Ben and JS's.
There we go.
C# script.
Mm-hmm. And then in 5 years, there'll be a new tool that everybody gets really into, and we'll start all over again.
Yeah. AJ, you joked about JavaScript being the new PHP with like copy paste Stack Overflow dev. Like
that's true.
That is simultaneously the best and worst thing about both PHP and JavaScript. It's really low barrier of entry for people who want to hack their way into it. but also results in some really badly built things. You have to take with the good with the bad if you want to have that barrier to entry be low.
Yeah. One other thing I want to throw at you guys is just that, Mikeal mentioned that like Webpack and things like that turn out to be the barrier for a lot of people. But for me, that's just part of the larger barrier that people run into. And that is just getting an environment set up that will run in the first place. And so it's not just Webpack. It's, okay, well, I want to build an app with Express and React and this and that and the other. And so then I have to make sure I have an up-to-date version of Node. I have to make sure I have an up-to-date version of NPM. And then I have to make sure I'm pulling in the right versions of the packages that I need. And, back to one of the other things we talked about, I've got a tutorial that's telling me to install out-of-date things, or I have the latest version of Node that isn't compatible with the version of whatever that they're telling me to use. And then you get into these other gray areas where I'm not super familiar with command line, and a lot of the tutorials on how to install Node in the first place tell you to use the command line, right? And use something like Homebrew or apt or whatever. And if you're on Windows, then you go download some installer, and then you've got to figure out where it landed and what it's doing and where the executables are and how that all works. And so what it really comes down to is Node does this better than a lot of other languages and systems. One example that I'm very familiar with is Ruby on Windows, just is pain. But the flip side is that it's still painful. There's still friction there, because if you're not familiar with how these things work, Mikeal mentioned that it's close to the metal. And so if you don't understand the metal, you're going to have some growing pains as you learn how this stuff goes together. And so you can't just install JavaScript, install Node, and just be off to the races. It doesn't quite line up that way.
So one thing I'll say too that's important here, because when we started Node School, which is like a bunch of tutorials and also sort of local meetups for people to learn Node, when we started doing the in-person ones, we noticed that people were having huge issues just getting it installed and configured properly. We've been able to fix a lot of those problems, but only in the install path that you flow down if you go to nodejs.org. So if you go to nodejs.org and you say install this, and then you'll see different options for installing it, potentially even tutorials if you get into some of the advanced stuff. If you follow that, things will get set up properly. Do not use Homebrew. Do not use, like most system installers. Most system installers will mess up the permissions on NPM. And then it's a lot of like manual work to go in and try to fix that.
And give you a 10-year-old version.
Yeah. Well, that's like, I don't want to get into the Debian community. Their whole thing. There are
stable unless it's moldy.
There are certain people who mostly have really old gray beards, and they just fundamentally believe that something that is old is more stable and more secure, even when all of the people that build it are telling them that's not true. And they insist that they will ship old versions because the new thing is not stable.
When it
There's
comes
no
to
reasoning.
programming, I can never use anything like Brew or app. Like I always go to the website, no matter which language it is. I try to just go to the website and get it because it's way better story.
Yeah. I mean, Homebrew, to their credit, is doing a better job than most Debian releases, but you still run into these permission issues. And the Node project's ability to fix these problems is pretty close to zero, because it's very difficult to work with a lot of these package managers, and just the bandwidth isn't there. And so we've been able to fix it in the standard install path. Also, you mentioned Windows. So Node works better on Windows than most modern platforms. And that was very intentional. The project wanted it to work well on Windows early on. Microsoft invested early on and actually put in money and resources into making it good in Windows. And so it's just much better. And a lot of that was that Microsoft themselves did not want to have a repeat of what happened with PHP, where PHP has just never felt nice on Windows. They really wanted it to be like a first-class citizen and use a lot of their operating system, the advances that had happened in their operating system around non-blocking I/O. So yeah, and also we got a huge number of users from that. I mean, I think still more than half of Node's users are on Windows. As sort of .NET declined in growth, we saw a noticeable uptick. It's also one of the reasons why we're overly represented actually on Stack Overflow, because Stack Overflow is a pretty Microsoft heavy audience. One of the first communities they brought in was a .NET audience. So
yeah, I definitely hear you there. I think one of the issues you have with the standard install path that you're talking about, though, is that like on Windows, you just run the installer. I think on Mac you can as well. I haven't installed Node in a while, and now I just tell it to update, and it just updates. But the thing there is that, like, for Ruby or PHP or a lot of these other systems, if you want to install something, you go to the command line first. And so that's, I think, why people wind up starting with Homebrew if they've got experience in some other system, is because that, that's where you start. And so anyway, it's really interesting just kind of see where we end up with this.
Yeah, and I mean, so we also we have like Debian packages like set up so you can use apt. You just need to like make sure that you pull from this particular app server in order to get the right thing, and then that will work really well for you. We also have the Node project releases official Docker images as well. So if you're doing anything with Docker, you can literally just say use node :10 or whatever, and it'll be fine. Yeah, so that gets the install out of the way of using Node and Node Basics. Once you get Node, you'll have NPM. NPM is what you'll use to install packages and potentially publish packages if that's something that you want to do. NPM is really well documented, has every feature ever, apparently. And their registry has a really nice website for you to search for packages when you're looking for, a package that does something, if you need a particular algorithm or whatnot.
Cool. There
we go. Them's the basics.
Nice. This episode is sponsored by Linode. Linode is offering listeners of this podcast a $20 credit, which is good for 4 free months at their lowest plan. Their plans start at 1 gigabyte of RAM for $5 a month. You can get your servers in any of their 10 data centers, and their high memory plans start at 16 gigabytes. Get a server running in under a minute. They do hourly billing with a monthly cap on all plans, and add-on services like backups, node balancers, Longview, etc. VMs for full control, running Docker containers, encrypted disks, VPNs, etc. You can run a private Git server. They provide native SSD storage, 40 gigabit network, and Intel E5 processors. They have 24/7 friendly support, even on holidays, and a 7-day money-back guaranteed. So go check them out at linode.com/JavaScript Jabber. AJ was kind of doing the running of the show, and he had to jump out for a meeting. So I'll take us into picks. Actually, I'm going to make Chris take us into picks.
All right, happy to do so. So I have 2 this week. Over the last couple of years, I've tried to move off of Chrome and onto Firefox as my development primary browser multiple times, and I always find myself coming back to Chrome. But
I was going to say half of our users just went, "Why?"
Yeah, well, so I finally officially made the jump. I don't know how much of it was because Firefox has gotten that much better over the last couple of years, and how much of it was just sheer willpower. But the long and short of it is, there's a couple of things for me. The first is Google just controls so much of the web and has access to so much of kind of what we look at and what we search for, et cetera. And something about being additional fuel for their massive advertising engine just kind of sat wrong with me. The other big thing, though, was with the announcement of Edge also moving over to, Blink as their rendering engine, and WebKit /Blink becoming kind of the primary thing on the web. I felt like it was really important to support Firefox, make sure that their work continues to have a place in the modern web. And I'm with you. I love WebKit. I love the console debugger in Chrome. I think it actually does a better job than Firefox. But there's so many really nice things about Firefox. In particular, I found that at least on my machine, it's actually faster to boot up and faster to load pages now than Chrome is. I don't know how much of that has to do with my kind of unique kind of plug-in extension setup or whatever, but basically this is just kind of a call to folks that if you haven't tried Firefox in a while, give it a shot. You may be pleasantly surprised, you may hate it, and that's okay. I certainly don't really care what people use as their browser, but I was really pleasantly surprised after not using it for 8 or 9 years, other than for periodic browser testing, things like that. Second, in end of September, early October this year, I am going to be speaking at Artifact Conference out in Austin, Texas, about a topic called the lean web. So basically all of the stuff you hear me complain about here on the show. I think I mentioned this last week too, but I just wanted to kind of redrop it because the conference is really that good. It has ruined all other conferences for me. It's kind of the gold standard in my mind. So you should definitely come check it out. Even if you just want to come there and tell me how much you suck and I suck rather, and you're sick of hearing my voice on the show. So that's it for me this week.
Nice. Yeah, the whole Edge move over, that's just exciting stuff. I need to see if I can line someone up to talk to about that. Aimee, What are your picks?
I do have some. So people probably know this from stuff I've picked in the past or just knowing me personally, but I kind of have like a mild obsession with like neuroscience in the brain. So this one it's called A Magician Explains Why We See What's Not There. And I love this kind of stuff. So that's going to be my first pick. And the other one, I have picked something similar to this in the past, but I don't know. I think this blog post got a lot of attention a couple weeks ago, and I think it's worth calling out again. And it's basically, the premise is, as engineers, we can either like spend our time writing tons and tons and tons of code, or we can kind of be more deliberate about it. Like you can kind of just be a factory and pump stuff out, or you can be more deliberate about it. And, you know, I don't know, the blog post just kind of talks about how some people, you know, view it more as a craft and things like that. So it's based on, I guess, this art teacher gives people like, again, this is what I talked about, I think like a year ago, this art teacher gives people like the job to make a bunch of pottery, and he has like one group and they're only allowed to make one, but they have to, and they measure like what it looks like at the end. And then this other group just like pumps out as many as they can, and they measure like the very last one and the quality of it. And the group that like spent time on just one of them, the quality of that one was better. So anyways, that's going to be it for me this week.
I guess I'm up.
Yeah, go for it.
So what I've been working on for the last year or so, and really like sort of in the background for like 10 years, is what a sort of more peer-to-peer decentralized web would look like. And, you know, that started with some CouchDB stuff that I did a long time ago, and it's changed quite a bit. We have new primitives in what we're calling kind of content addressing that allow just a much different, a very different way to think about web development and to think about how we use the web for not just websites, but also the data behind them, and making that whole platform kind of come together. So I gave a talk at Cascadia on this that's like a pretty good introduction. So if you just search for my name in Cascadia.js, you'll find it, but also I'm sure there'll be a link in the show notes. I just put it in the chat. And it's just about, you know, what the future of the web looks like, the challenges that we're dealing with. The kinds of like problems that we see in Twitter and Facebook are really like the reason that we can't solve them as a community is because they are all built the same way. And we have not yet upgraded the web to be able to deal with, to even build applications in a different way. So if you wanted to build a social media app tomorrow that didn't suffer from a lot of the same problems of Facebook and Twitter, you actually can't. You just don't have those primitives yet. So this is the kind of stuff that we're working on. And and then keeping with the browser theme, I'm going to plug a browser too. I'm going to plug Brave because Brave is awesome. And so Brave, under the hood, Brave does use Chromium, but Brave is going like an extra couple miles in terms of protecting your privacy. It's much, much more aggressive than just any other browser in terms of how much it will block. In what ways that it will block not just ads, but also different tracking and fingerprinting and stuff like that. So
we need to have an episode on this because I think Brave is a really shady browser, and I'd love to talk about it more.
Shady. It's not shady.
It's not the time, but
it is not a shady browser.
Browser wars.
I mean, so
Mikeal
you can have
Rogers.
Brendan on. So Brendan Ike, who invented JavaScript, is the CEO of Brave. You could have him on. He can actually. I used to have a podcast with Nadia Eggball where we talked about open source sustainability. It's called Request for Commits. We did an episode with Brendan Ike that was really about how browsers have been funded and the sort of evolution of browsers. So if you're interested in that kind of topic and where browsers came from and how much money it costs really to do a browser 10 years ago and today, I would definitely check that out. It's a really cool episode. Yeah, there you go.
Nice. Is that podcast still running?
No, we did 2 seasons. We did it differently. It wasn't like an ongoing. We had
Right.
2 seasons of like stuff that we really wanted to talk about, and then after that, we were like, we're sort of done talking about this topic. And so Nadia has done a new podcast with Henry Zhu called Hope and Source. Yeah. And it was released like Netflix style, like just the whole, like a whole bunch of episodes at once and then like no more basically. But it's about sort of the intersection of like faith and religion and open source. And it's very interesting because Nadia's not religious at all and Henry is. And it's a phenomenal podcast actually. Like you should definitely listen to that one as well. But yeah, the Request for Commits, we did a couple seasons. Every episode was just going really deep with somebody on the challenges of being an open source maintainer and what open source sustainability looks like. So
Makes sense. Yeah, we are starting an open source sustainability podcast on devchat.tv. I'm talking to the bunch of people that are going to be involved in that next Monday, and we'll finalize the recording schedule and start rolling with that. So
cool.
Should be fun.
Awesome.
All right. Well, I guess I have a couple of picks I'm going to throw out here. First of all, I think I've mentioned a few times on the show, I'm working on a system called PodWrench. If you're doing podcasts, it's a podcast management platform. But the real crux of it is for me is that a lot of content creators get into podcasting and then they get back out because producing audio is kind of a pain. The other thing is that they have to spend a bunch of time, doing that stuff instead of just creating content. And so what I'm trying to do is create a platform where you essentially, we find you sponsors, we pay your production team, or we give you the money and you can pay your production team. And then you just show up and record. And, the tool does all the management stuff as far as when you upload the file, it lets the editor know. When the editor's done, it lets the show notes folks know. When the show notes folks schedule stuff, it lets you know, lets your guests know, lets your host know when to show up, gives intros to all of your hosts and guests, all that kind of stuff. So it just makes it so that you can just show up and talk about the stuff you want to talk about. And then it does the rest of everything else for you and reminds you what you need to bring up on the show to pay the bills. So anyway, it's at podwrench.com. And I am going to be looking for beta testers. This show's like 4 or 5 weeks ahead, so I will definitely be looking when this episode comes out. So definitely go check that out. And then, I think we should do a Browser Wars episode, but we'll dive into that later. But let's go ahead and wrap this up. Thanks for coming, Michael.
Thanks for having me.
All right, folks, we will wrap this up, and we'll be back next week.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.